Welcome friends. In this video I'm going to explain or brief about the basics of probability theory. Here first I would like to define what is a random experiment. That experiment or a trial, the experiment or trial when you perform repeatedly is giving different results are known as random experiment. That is, very simple example, common example is whenever you toss a single coin, every time we are getting a outcome we are not expecting, whether it is getting a head or a tail, or whenever you roll a die, 6 outcomes you may get, but we are not expecting that. That's why that is known as we are doing experiment. Okay, like that, drawing a card from a deck, all these are examples for random experiment. After random experiment, sample space, a set consisting of all possible outcomes of a random experiment is called as a sample space. Whenever you are doing any experiment, some possible outcomes will be there. That is, whenever a single coin is tossed, at that time your possible outcomes are you may get head or tail. This set is known as a sample space. Or whenever you toss two coins, then the possible outcomes are head. First coin and second coin both may get head, or first coin may get head, second coin may get tail, like that. First coin may get tail, second coin may get head, or both the coins may get tail. This is our possible outcome. Or whenever a single die is rolled, okay, the dots, the facing up are number 1, 2, 3, 4, 5, 6. These outcomes may come. The set of all possible outcomes whenever you are doing a random experiment, that is known as a sample space. Or another example, whenever two dice are rolled at a time, okay, then we may get first may get 1, second also may get 1, first may get 1, 2, 1, 3, like that, up to 1, 6 you may get, then 2, 1, 2, 2, like that, 2, 6 you may get. Similarly, what you may get, 3, 1, 4, 1, 5, 1, 6, 1, like that, up to 6, 6. Total 36 outcomes you may get. This set together is known as a sample space. Okay. After sample space, I would like to define an event. An event is a subset of this sample space. For a particular condition. I will define one event on the sample space. Yes, whenever a coin is tossed, event I will define it as getting a head. That is condition I am putting as a getting head. Therefore, that is nothing but a single head you may get. Or whenever two coins are tossed, I will define event as getting at least one head. At least one head. Then that set will become head, tail, head. This is a subset of this. Therefore, event is nothing but a subset of sample space using a particular condition. or in this event I will make it as a odd number, that is 1 3 5. This is like that. Some may I make it less than 2, like any condition you can make. That is nothing but your particular event. Okay, or happening, number of possible happenings of a particular condition are known as a event. Okay, like that. In that event, exhaustive event I will define an event consisting of all various possibilities is known as exhaustive events. Okay, if that event is also with a set of same sample space, then that is known as a exhaustive event. Like that, mutually exclusive event, there is two or more events are said to be mutually exclusive if happening of one event prevents the simultaneous happening of the other. Okay, in a single toss of a coin I have defined one event E1, I will call it as getting one head. E2 I will define it as tail. Therefore E1 and E2 are not depending on each other. The happening of E1 and happening of E2 preventing the happening of each other. Therefore they are known as mutually exclusive. Or one more definition I can make, if E1 and E2 are mutually exclusive, intersection of the two sets, here E1 intersection E2 is a null set, then we say that E1 and E2 are mutually exclusive events. Okay, here E1 in the second example, that is whenever two coins are tossed, E1 I will make it as at least one head, and E2 I will make it as at least one tail, at least one tail. At that time this will become head tail, tail head, tail tail. But here for E1 and E2 there is a common thing, head tail, tail head as common. Therefore E1 and E2 are not mutually exclusive here. They are not mutually exclusive. There should not be common between two. Such events are known as not mutually exclusive. In the third case example, if whenever a die is rolled, E1 I will make it as an odd number, E2 I will make it as an even number, that is 2 4 6. Therefore E1 and E2 are mutually exclusive events here. They are not depending on each other. Okay, such events are known as mutually exclusive. Then like that, independent events, if the happening or non-happening of one event does not depend upon the happening or non-happening of the other, then those events are said to be independent. Okay, E1 and E2 are independent. Okay, such events are known as independent events. Like that, let me define now probability of an event. If cardinality of S, that is the sample space, order of an S is equal to N, is the cardinality of a sample space S of a random experiment, and order of E is equal to M is the cardinality of an event E of a random experiment, then the probability of an event E is defined by a real number. Probability of E is equal to order of E divided by order of S, that is nothing but M by N. Say here S is nothing but whenever single coin is tossed, S is nothing but head tail. Therefore order of S, is equal to 2. Whenever a single coin is tossed, order of S is equal to 2. And getting head E1 I have made, therefore order of E1 is equal to getting a tail, getting a head, that is 1. Therefore 1. Therefore probability of this E1 is equal to 1 divided by order of E1 divided by order of S, that is equal to 1 by 2. Similarly, order of E2 is tail, only single wave, therefore that is also 1 by 2. E2 is also 1 by 2. Like that, whenever two coins are tossed, order of this S, here total 4 possibilities are there, order of S is equal to 4, and even I have mentioned it as at least one head, therefore the possible outcomes are 3 are here, therefore its order is 3. Probability of getting this particular event at least one head is 3 divided by 4. This is the probability of getting at least one head or at least one tail. Okay, like that. Here odd is also 3 by 2, 3 by 6, 3 by 6, that is also 1 by 2. This is how to define the probability of an event. Now some note on this I would like to discuss here. Usually probability of happening of an event is denoted by small p, or we call it as a probability of success. Okay, happening, if I define as a success, then probability of happening p, small p, is denoted by m by n. Therefore non-happening of an event will become e bar. Then order of e bar is equal to, we know that, order of S minus order of E, that is n minus m. And the probability of non-happening of an event is denoted by, usually it is denoted by q, that is n minus m divided by n, 1 minus, therefore q is equal to 1 minus p, therefore p plus q is equal to 1. This thing I am going to use further in the next explanation. Okay, 1MAT. Okay friends, please subscribe my channel and press bell icon for more updates, and please give the comments for updates. Thank you friends.